So for part 2, here we have those 2 steps, right? When we try to complete a square, we go through those 3 things, figure out what b is. In this case, it's 14 divided by 2, which gives us 7. Second step is to square it, and then we add it on to our original equation, which was x squared plus 14x. By adding on 49, it becomes a perfect square, x plus 7 squared. And in this next example, although this expression changes, what it does is once we complete the square, we add on those solving steps from the first part, from the do now. The key step I want you to pay attention to is, switch to purple, right here. Okay, where did this 9 come from? 9 comes from, as you see on this side, right? 9 comes from 6 over 2 squared. That's your b value right there. We needed to add 9 to both sides so that the original equation doesn't change. Notice if we covered this part up right here, that's a totally different equation than what we had initially. So once we add on 9, we've made a perfect square on the left-hand side. We're going to deal with the stuff on the right-hand side like so. Okay, simplify it. X squared plus 6x plus 9 gives you x plus 3 squared. 16 plus 9 gives you 25. Take the square root of both sides. We're left with square root of 25, which is positive or negative 5, minus 3, and this is what leads us to our 2 answers. Okay? Let's go through a couple of examples where a is still 1, and we're going to complete the square and then solve for x. So here's your first equation. We have x squared minus 6x plus 8. We'll follow through the book's first steps. Let us first subtract 8 from both sides, which gives us this equation. Next, I figure out my b value. I'll do this along the side. B here is equal to negative 6. Then I'm going to divide it in half, which gives me negative 6 over 2, negative 3. And then I'll square it. That's step 3. So I have 9. We need to add on that 9, which I'll emphasize with an underline. Don't forget to do it on both sides so you don't change your original equation. From here, we recognize that this whole thing is your perfect square. So it becomes minus 3 over 2. How did I get minus 3? Well, that's just half of negative 6. That's this factor in your perfect square. b over 2 squared is c. b over 2 is what goes here. Negative 8 plus 9 gives us 1. Take the square root of both sides, because now we're solving for x now. X minus 3 equals plus or minus 1. The square root of 1 is 1. Add 3 to both sides. So then x is equal to plus or minus 1 plus 3, which gives you positive 1 plus 3, which equals 4. And your second answer, negative 1 plus 3, which gets you negative 2. Right? Darker purple. So far, so good? Any questions? Let's go through another example. Feel free to ask them. We'll work on these on your own and I'll narrate through the process. Okay, first step. Let's get it looking like this by subtracting 5 from both sides. My b value here is negative 6. b over 2 is negative 3 again. b over 2 squared is negative 3 squared. So that's same old 9. we add that in to complete the square. Simplify negative 3 squared, just like the previous example. 9 plus 5 is 14. Take the square root of both sides. Do my math right? Yeah. Oh, no, I didn't. There's a mistake. All right, it's not negative 14. It's negative 5 from that first step, so this is 4. There we go. So this becomes x minus 3. Square root of 4 is 2. Plus or minus 2. Add 3 to both sides. So that gets us x equals, you can write it this way too, 3 plus or minus 2. Order doesn't matter as much. It'll matter when we have a square root, and I'll go over why the square root comes second when we get there. Positive 3 plus 2, positive 3 minus 2, those are our two answers, 5 and 1. That's the second example, completing the square and solving for x. I think I got 2 more examples, and then we'll go on to the case where a is not equal to 1. It's a little bit more complicated. So, first step, add 9, because we need it to look like this. We're going to add on something. We don't know what it is just yet. There's your 9 plus something. For me, sometimes I like to draw in these blanks as a placeholder because that's where my completing the square goes, that number. Over 2 squared. 2 squared is 4. Plus 4 plus 4. M plus 2, because that's half of 4. Conveniently, it's located right there. Equals 13. Take the square root of both sides. I'm writing it out for notes purposes, but you don't have to like write out the square over here. You could do something like this instead. Okay. M plus 2 equals plus or minus square root of 13. Subtract 2 from both sides. M is equal to, and you'll notice this is where it kind of matters. You'll see this written often as your answer, or you can write it like this, right? 13, that plus or minus comes first, and then add on 2, right? This one, preferred way, because sometimes when you write it like plus 2, some people can confuse that with this one, right? Versus 13 plus 2, like that. And so to avoid that mistake, you'll often see in math class, they'll write it this way, which just means 2 minus square root of 13, 2 plus square root of 13. Okay? Although this way, it's completely right, nothing wrong with it. You're just set up to kind of make these mistakes over here. All right, last example of completing a square where a is equal to 1. Minus 7, x squared plus something equals negative 7 plus something. B is negative 6. B over 2, negative 3. B squared, negative 3 squared, 9. All right, so we add 9 to both sides. Minus 3 squared. Negative 7 plus 9 is positive 2. Square root of both sides. X minus 3 equals plus or minus square root of 2. Plus 3 plus 3. Therefore, x is equal 3 plus or minus square root of 2. So there's 2 answers hiding there. All right, So before I go on to these problem, and this one, and this one, I think that's it, yeah. Those three, let's go over the example on page 414. So in this example, notice right here, a is not equal to 1. So we can't apply this b over 2 squared idea just yet. You have one additional step, which makes math a bit more complicated. You have to make a equals 1, so your first step is to divide everything by that a value, which is 2. So 2 over 2 is 1, 9 over 2 is here, 8 over 2 is 4, 0 over 2 is 0. Now from this equation, you subtract 4 from both sides, get here, your b value is now this fraction. It still works, b over 2 squared. You can complete the square with fractions. Okay, so y was 18 over 16 added to both sides, because that's b over 2 squared, right? Which was 9 over 2 divided by 2 squared, 9 over 4 squared, 81 over 16. So after that point, okay, that's the key completing the square step right there. B over 2, that's where it matters. This thing, right? That's b over 2 equals 17 over 16. Do some fraction arithmetic, and then we get our answers. And you could turn them into decimals, but you can just leave it like this, right? This is even acceptable. You can stop right here. That'll be good enough for me. All right, that's as complicated as it will get for Algebra 1. Later on Algebra 2, this is where they pick off and talk about more complicated examples. I find that this step right here is the hardest part about Algebra 1. Quadratic formula is no problem, right? Once you memorize it, you apply it. But this one, it involves like a whole bunch of different steps and a whole bunch of other operations that may come up, square roots, fractions. Okay, so we'll go through these three examples, and then I'll let you all go. You can ask me more questions on the classwork. I'll have it in front of me. And this is the part 2 to the lecture on completing the square. All right, so here's an example. A is not equal to 1, so we've got to divide everything by 2. Go through and write it all out again. Right, divide by 2, divide by 2, divide by 2, divide by 2. That gives us m squared plus 7 over 2m plus 3 halves equals 0. Subtract this from both sides. Now we got to a point that looks like the previous 4 examples. Okay. I'll rewrite this, draw a little blank, so I know that that's what I need to add on to complete the square. On the side, I will figure out what to do with b over 2. You can think about fraction division like that, if it helps. 7 over 4. B over 2 squared. 7 over 4 times 7 over 4. 49 over 16. Missy. So you'll see me write these 3 steps out a lot for completing the square. That's because I don't want to forget what b over 2 is, because that comes in handy for this next part. Like that. From here, maybe I'll multiply this by 8. I get negative 24 over 16 plus 49. 29, 24, 25 over 16. That ends up being pretty nice, because when I take the square root of both sides, so we know the square root of 25 over 16. m plus 7/4 equals 5 over 4. That's positive or negative. Take away 7/4 from both sides. M is equal to positive or negative 5/4 minus 7/4. You can figure out what that is. Positive 5/4 minus 7 over 4, left with negative 2/4, which equals negative 1/2. That's your first answer. Negative 5/4 minus 5/4 gives you a total of negative 12 over 4, which is negative 3. Okay. So not having an a value of equals to 1 gives you that much more work. Yeah, see why I call this the hardest part of Algebra 1. Okay, 2 more examples. Here they are. Maybe you want to do 4C while I do the first one to get some practice. I'll talk through 4B. So divide everything by 2. Over 2, over 2, over 2, over 2. R squared plus 1/2 r minus 3/2 equals 0. Add 3 over 2 to both sides. R squared plus 1/2 r plus something equals positive 3/2 plus something. B here is now 1/2. B over 2. You can rewrite it even like that as 1/4. B over 2 squared equals 1/4 times 1/4, 1/16. Right. R plus 1/4 is my perfect square. Times 8 times 8. I get 25 over 16 again. Convenient. Take the square root of both sides. Plus or minus 25 over 16. R plus 1/4 equals plus or minus 5 over 4. Continue going over here. R equals plus or minus 5 over 4 minus 1/4. So our two answers, positive 5/4 minus 1/4, 4 over 4 gets me to 1, negative 5/4 minus 1/4 equals 6 over 4, negative 6 over 4, negative 2, 3 halves. Can rewrite that in this here. Right, a lot of steps. That's why I assigned you the odds for today's classwork, so you can check it all over. Alright, last example. 3x squared plus 7x minus 6. Here we go. Now we divide everything by 3. X squared plus 7/3 x minus 2 equals 0. Plus 2 to both sides. X squared plus 7/3 x plus something equals 2 plus that something. Let's figure out what that something is. What am I missing to make this a perfect square? B here is 7/3. B over 2, we can think about it like multiplying by the fraction 1/2 is 7/6. B over 2 squared is 7/6 times 7/6, 49 over 36. 49 over 36. B over 2, nice and handy, we already have it written. 7/6 squared equals 72 plus 49 over 36. 121 over 36. Nice. Because the square root of 121 is 11, and the square root of 36 is 6. We know that. this whole mess is 11 over 6. Subtract 7/6 from both sides. X is equal to plus or minus 11/6 minus 7/6. So here are our two answers. Positive 11/6 minus 7 over 6, 4 over 6, 2/3. Second answer, negative 11/6 minus 7 over 6, negative 18 over 6, negative 3. Okay, that's all. More practice. Thanks, Rob.